Hi everyone. Good day, good evening, good afternoon, wherever you're joining in from. We will get started with the meeting in just a bit. I am waiting on few more folks to join in if they wish to, and we'll start within 5 minutes of the scheduled time. Scheduled time. Sorry. Would that be okay with everyone?
Yes, let's start it 5 minutes later.
Yep. And in the meantime, I will also share my screen so that everyone's able to see the agenda items for today. And I'll also share the agenda items on the chat so that agenda doc on the chat, sorry, so that you're able to make any amendments to that if you need to as an attendee, add in any discussion items or whatsoever that you need to do. So just give me a moment. I'm trying to get that screen up. So the agenda doc is on the chat right now. And to gain the right access to this doc, please ensure that you are signing up to our list, that is the CNCF list. And I'm going to paste that as well on the chat. So if you have access to one of these lists, or if you've subscribed to one of these lists, you should have the access. And I'm also going to hit share in just a moment so that everyone's able to see the document. All right. I assume that we're able to see the document right now, and in just another couple of minutes, we will get started. Oops. All right. In the interest of time, I am going to get started with the meeting right now. So, welcome to whoever is joining in or whoever is watching this recording later on. I am Divya Mohan, and I work as a principal technology advocate at SUSA, and I'm also the community manager for Longhorn. So you'd probably see me around on the Slack channel and in various other fora talking about Longhorn and hosting virtual meetups, etc. Now, today we are here for the monthly community meeting, which basically focuses on updates from the Longhorn project. And of course, you can interact with our wider team shows here from the Longhorn team back at SUSE. He's a colleague. And we'll be delving into some interesting features from the latest release, contrast them with the previous release. And of course, we also have our regular set of updates that we normally deliver at every meeting. So, yeah, so let's get started without further ado. The In the updates and reminders section, it's majorly just a call out for any adopters who are already using Longhorn in their infrastructure at their workplace. If you wish to share your story about Longhorn and how it has helped you simplify your cloud native storage capabilities within the infrastructure that you're using, please do consider submitting a PR to the Longhorn/Longhorn GitHub repository. It's linked on the agenda documentation, and you can easily even find it on github.com/Longhorn/Longhorn if that is too much of a task to go and navigate to the agenda doc. And not only does this help bring your story to light in terms of how you're using cloud native tools and technologies effectively within your infrastructure, but it also helps us build our path towards CNCF graduation, which we are targeting in the next year or two, sorry. And essentially this would be a show of support if y'all are able to do so. And yeah, that's the spiel for the adopter list updates bit. And coming to the major topic for today, which is the version 1.10.0 release, which happened a couple of weeks back. We hosted David Coe, who's the engineering manager, but also the maintainer for Longhorn, one of the maintainers for the Longhorn project. And we had a brief overview of what the features and what the updates were in the latest release. If you did not catch it, do not worry, it's up on YouTube as well as on the LinkedIn profile for Rancher, since global online meetups are hosted by them. And we've covered a breadth of topics ranging from community updates to documentation updates to even obviously the newer technical features that are introduced in the latest release. And we do have call outs for people who want to get involved in any capacity ranging from code to documentation to even community contributions. So if you've missed that global online meetup, I urge you to go and check out the recording. Again, available on Rancho's YouTube channel, and it's clickable from the agenda doc that I just shared with you. But outside of that, we obviously have the Longhorn Basics course on Rancher Academy, where I mean, this is not a plug for Rancher or anything else, but this is a course that was formulated to teach people more about Longhorn from the very scratch. So if you're interested in learning more about it, please go and sign up. And as usual, we do have our shout out section wherein we recognize creators and curators from the community who have used Longhorn and shared their stories through blogs, through videos, or through any other formats. This month we've had Mahdi Shadi, who has written a blog on using Longhorn for seamless scalable storage in his workplace's Kubernetes clusters. And if you haven't read it already, please do go check it out. It's again linked in the agenda doc. And this for everyone who's watching this, I know you're probably going at this point saying, okay, where is the update that we were promised about version 10.0 and version 1.9, the contrasting features and all of that? So just one little tiny PSA before we move on to that. If you would like to share your stories in the form of blogs or whatever else, please do tag us on any of the social media platforms, and you could also be featured on our October shout out section next time around. With that, I will now hand it over to Shuo to take us through the next section, which is the Longhorn sprint walkthrough, or we can also go through the contrasting features, whatever you please show. Please take it over from here.
Okay, thank you, Devya. So yeah, let me share my screen, then we can start to walk through the highlight feature in the past two minor release. I mean 1.9 and 1.10. Oh, wait a moment, can't. Can it share the whole screen? Yeah, yeah.
All right. Yeah.
So
See that.
yeah, can you see my screen? Yes.
Yes.
So yeah, okay, let's get started with the presentation first. So let me start from this one. So first of all, let's introduce some highlight features, mainly related to the V2. So as you know, in the recent years, Longhorn is focusing on developing and building the second version of the volume engine, which provide a more powerful performance and a kind of reasonable resource usage. So right now, the V2 engine is still in experimental stage, but yeah, after we develop all, let's say, feature pairs, so then we can announce it to alpha, beta, then GA. So anyway, the implementation is still in progress, but I think the majority of the feature sets is ready. So let's introduce it one by one. And oh, okay. By the way, why we need for the new users to Longhorn, they may not understand too much about why we need the second generation of the volume engine. This is, as I mentioned, it provides a much powerful performance compared with V1 engine. So here is the benchmark results already recorded in our official website. If you launch your official website and scroll down to the bottom, you will see V2 data engine related introduction. So we used, let's say, two platforms to do the benchmark and compare the performance between V1 and V2. And here is the result. So as you can see here, first of all, for the IOPS, I mean for the random IO, if a volume has only one replica, the difference is already doubled. But if you say that when there are more replications for a volume, then comparing the yellow and the red columns, you will see the performance will be over 3 times sometimes, especially in the write performance. Yeah, in V1 with 3 replicas, the IOPS is no more than 20,000 per second in this case. But if we switch to V2 with the same, let's say, 3 replicas, the random write performance can reach to over 60%, 60,000. That's a huge difference, and this is why we need to introduce the second generation of V2 engine. And for the bandwidth, yeah, for the sequential one, yeah, it's so you will see the performance is a slightly better than the V1 because so for the bandwidth part, I don't think typically there will be too many bottlenecks. But if we then switch to the latency, you will still see the huge difference here. So comparing with V1 and V2, both in one replica case and in three replica case, so V2 data engine has a half or even 1/3 latency comparing with that of V1. That's the power of the second generation of data engine. And of course, this kind of powerful performance has its price. The price is that comparing with V1, V2 data engine, it at least, let's say, one virtual cores per node with extra, let's say, dedicated huge page set in your cluster. So for both CPU usage and the huge page, you can set it in the actual Longhorn, as I shown here. So for example, if you just want one dedicated CPU, you can use this mask. This mask means we will reserve and consume the first CPU dedicated for V2 data engine. And besides, you need to set the memory size, which will be the huge page dedicated for the V2 data engine as well. But anyway, the resource consumption is reasonable comparing with its powerful performance. Yeah, I think as for how we can start to use V2 data engine, the quick start guide and the prerequisite will record all details. If you are interested, you can check and try it after the meeting. So I think the documentation is in detailed enough for you to use it, to play with it. And yeah, that's a basic of the V2 data engine. Then let's switch to the highlight feature we introduced in the recent 2 release for V2 and even for general cases. So first of all, in the past 2 releases, we did a lot of improvement for the rebuilding part for V2 volumes, including fast rebuilding. Fast rebuilding typically means reuse some intact data inside the failed replica, and then correct the corrupted part quickly. So compared with the full rebuilding, I mean rebuilding from scratch, reusing those existing data may definitely save a lot of time and network bandwidth in the cluster. And for this feature, which is also our main demo content in this meeting, and then we also introduce 2 kind of clone style for V2 volume, full clone and the linked clone. Full clone, yeah, it's like a regular clone shown already in V1 volume. So it will copy all content, all valid content from the current V2 volume to a brand new, let's say V1 or V2 volume. And besides this, we also introduce a special clone pattern named link clone. This clone is like create a special snapshot for the current V2 volume, but it's shown as a new volume. Then later on, users can rely on this special linked clone volume to do some kind of special, let's say, snapshot or even external backup operations. So for these features, if you are interested, you can check the latest blog posted in our website, which tell you how to rely on this new feature to backup V2 Longhorn volume content into Valero, via Valero, and then into the third-party solution, for example, some kind of external S3 or even uh, other kind of storage system. And besides, we also introduce V2 volume life expansion. This is simple, straightforward, but it's extremely important. Then we also implement the interrupt mode for V2 volumes. As I just mentioned, typically if we want to run V2 volumes, you need to prepare a dedicated CPU for it. But interrupt mode allow you to, let's say, start with 0 dedicated CPU for V2 volumes. This is kind of special mode in V2 volume. It can use much less CPU resource if the system in general is idle, but the price is that the performance will be degraded. So with this feature, V2 volume can, let's say, can be adopted to both, let's say, high spec environment, but also the low spec environment. I mean, with limited CPU scenario. And then we also introduced configurable backup block size. This feature is for both V1 and V2 data engine, because with a larger backup block size, we can have a more efficient backup. This will definitely increase our backup speed, as well as save more kind of extra API usage if you are using some kind of external storage like S3. And then we also improve the offline rebuilding for both V1 and V2, which have a better scheduling awareness. Even the volume is degraded, but even if the volume is detached but degraded. Yeah, and and then we also consolidate V1 and V2 settings, because if you look at the previous setting page, for the same kind of configuration, V2 and V1 have, let's say, separate setting options, which is inconvenient or it's not straightforward enough for the users. And in the recent 1.10 release, we just merge them together, and for each, let's say, setting, or for each configuration, you can see both V1 and V2 status in the same section. So we can have a quick demo it later. It's pretty straightforward. And then we also fix a lot of bugs for the volume attachment part, for the backup, for Oven, and for V2 data engine specific issues. Yeah. And I think that's a highlight work in the recent 1 or 2 release. Any questions? Okay. If not, then we can go through the next page, which is the main topic in this in this meeting. We will talk a little bit more about how V2 fast rebuilding works. As I mentioned, it's similar to V1 fast rebuilding features. So how it works? First of all, for existing snapshot in healthy replicas, we will calculate the snapshot checksum in advance. I mean, based on the user's configuration, we will trigger the snapshot checksum calculation in a specific time. Then later on, if the replica becomes failed and we want to reuse this kind of failed replica for the rebuilding, then we can check if the failed replica has a snapshot checksum in it. If yes, and the snapshot checksum match the result from the healthy replicas, which means the corresponding snapshot in the healthy replica is intact, and we can skip the data transfer for this kind of intact snapshot. That's the basic idea of volume fast rebuilding in Longhorn. Both is this kind of rules or this kind of ideas apply for both V1 and V2. Then what's the difference? First of all, the checksum algorithm is different. The snapshot for V2, the snapshot checksum use CRC 64 checksum list. Why we say it's list? Because in V2 we will calculate and store the checksum result for each data chunk. In V2 we call it cluster, which is a 1 megabyte data chunk. So as a result, for let's say if a snapshot has 1 terabyte actual data, then which means there will be and based on this result, based on the fact list here, we will consume extra 12 megabytes memory and disk storage to store the checksum result. I think if you have so many data on a node or in a disk, which means your node is not a low spec node. I think for this kind of memory consumption, it is acceptable. And with this kind of snapshot list, rather than a simple snapshot, with such a snapshot checksum list for each snapshot, rather than a simple checksum result, Longhorn can quickly figure out and transfer the mismatching, let's say, data chunks for partially corrupted snapshots only. It can skip the intact part of a snapshot and just correct the corrupted part. So this can further speed up the fast rebuilding. I mean, we can have a higher efficiency of reusing the existing data during the rebuilding. That's the main idea. So here there will be 2 illustrations of how Longhorn rebuilding works. So let's talk about the general and the big flow first. Let's say if for volume before the rebuilding, at least there will be some healthy replica, right? So let's pick up one healthy replica as the source of the rebuilding. Then we will add a new rebuilding replica with write-only mode. And first of all, we will pause the I/O, create a new snapshot for the healthy replica. Then the previous volume head data content will be the content in the latest snapshot. Then we will expose this latest snapshot content to the rebuilding replica, and based on this exposed content, we will create a new temporary volume head for this rebuilding replica. Then at this moment, no matter if you read from the healthy replica or read from the rebuilding replica, then you will always get the same content, because let's say after this, if you read some content from the volume head, let's say during copy on write, then if the content is not shown in this temporary volume head, we will retrieve back to this exposed snapshot content inside this healthy replicas. With this operations, then there won't be inconsistency between healthy replica and this rebuilding replica. Then we will, after this, we can rebuild snapshot one by one. Once all snapshot in the rebuilding replica are ready, we will, let's say, reorganize this snapshot chain and then switch this rebuilding replica from write-only mode to read-write mode. Then after that, the rebuilding should be complete, and this new replica will be marked as healthy, which is then identical with the previous, with this healthy replica. So that's the general flow for the Longhorn volume rebuilding. Then let's talk about how we rebuild a single snapshot inside the previous general flow. So let's focus on the V2 fast rebuilding part. As we mentioned, first of all, we have a source replica snapshot listed in the left, which should be the correct content. And on the right part, let's say for the destination replica, which is the rebuilding replica, it already has a corresponding checksum, but it's partially corrupted. Then with our new, let's say, fast rebuilding, let's say, technology, we can efficiently reuse the existing data in this, let's say, partially corrupted snapshot for the rebuilding replica and quickly finish our rebuilding for this snapshot. So first of all, we will check the first data chunk or let's say the first cluster between the snapshot, because they have the identical checksum, then we can skip it. The second one, still skip it since they are identical. Third one, skip it, identical. But for the first one, we will see there are difference, which means this data chunk in this rebuilding replica is corrupted. Then we will transfer this data chunk only. Then the fifth one, both are empty, then we will skip it. Then the sixth one is corrupted, then we will do the data transfer. And similarly for the next one, we will the same. This is empty, but here there are already some content, then we will do data copy. Then for this one, it's identical, so we will skip it. Then for the next one, as we can see, in the healthy snapshot, this data chunk has no content, but in the corrupted one, it has some kind of weird content. In this case, we will do unmap, which will erase. We will erase the content inside this corrupted replica. And the last one will skip it. After this, these two snapshots should be identical. That's how we efficiently reuse the existing and valid data chunks in the failed replica in the corrupted snapshot, and then which will boost the rebuilding progress, make it faster. So that's the basic illustration and idea for this V2 fast rebuilding feature. So any questions?
No, none from my side. And I believe the one person who did end up coming to the meeting actually ended up dropping because of some reason. So, yeah, we can
Okay.
continue this because it's being recorded. I have no concerns. But yeah,
Okay. Okay, then let's directly continue without any further question
yeah,
QA
yeah,
section.
yeah.
Okay. So so to demo the power of the V2 fast rebuilding, let's introduce the our demo step first. First of all, we will prepare some data chunks and create some snapshots based on those data chunks for V2 volume. Let's say there will be 3 snapshots later, which each snapshot has, let's say, some data chunks, and then we will corrupt it one replica for a while, and after this replica failure, but before the rebuilding, we will apply some hacking operations. Those kind of hacking operations mocks a real use case. Because why? Because typically there will be some snapshot operation before the rebuilding. Before rebuilding the failed replica. I mean, after the replica become a failure, but before this failed replica get rebuilt. So during this moment, typically there will be some change in the existing snapshot chains. So we will use some hacking operation to mock this kind of change. After this kind of hacking operations, the snapshot content between the existing healthy replicas and the failed replicas will be inconsistent. Then later on, when we try to do rebuilding for that failed replica, and we can see if Longhorn can really reuse the intact data content inside this corrupted, let's say, failed replicas, even though there are some mismatching. So first of all, we have an existing cluster here. Then I will run this script. This script will do what we just mentioned. I mean, prepare a V2 volume and write some data chunks and create some snapshot. Then fail one replica. Then continue issuing some hacking operation to make the snapshot content between existing replica and that of the failed replica different. Then after that, we will apply the rebuilding and see if the fast rebuilding work as expected or not. So let's run it. First of all, it will create a volume here. It will prepare some data chunks. This data chunk is already prepared in advance. Then it will copy this existing data chunks into the volume and create some snapshots. Snapshot 0 has 512 megabytes. And here is the let's say final checksum result. Then copy more data. And create snapshot 1. If you refresh it, yeah, it should be in the list. Then with snapshot 1, we also have a total checksum. Or of course, the separate checksum list as is stored inside Longhorn as well, but we won't show in the UI. Then one more snapshot 2. So there will be 3 snapshots in total. And after that, we will crash one replica. You can see here, it will be marked as failed soon. Yeah, marked as failed. And then let's smoke the general use case. Typically, some users will continue to operate the existing snapshot for the remaining healthy replicas, which makes the snapshot content different. Let's say in the failed replica, the snapshot content only contains these data chunks, but in the current remaining healthy replicas, there'll be some new data content shown here. And for the snapshot 0, the same. They are using these two replica. The replica has the same name, but the content is already different among failed replicas and healthy replicas. Then same for the snapshot 1, the data chunk is different as well. But in this case, this failed replica has some extra content shown here, which means after this, all the three snapshots have different content. I mean, between the failed replica and the healthy replicas. And then we can see later on if Longhorn can still reuse the intact content inside this failed replica and speed up the rebuilding. And besides, the healthy replica has a brand new snapshot 3, comparing with the failed replica. And after this, let's see. After this, we will start the fast rebuilding, and let's see if the rebuilding could get boosted by the existing content. If you let's somehow search, if you open the instance manager pod, you will and search reusable. Search this keyword, you will see here it will try to reuse the existing content in snapshot 2. Then you can see there will be a quick increment for the progress bar at the beginning because we reuse some content. Then we will reuse the content in snapshot 0. We will see a quick boost for the rebuilding bar as well after we reuse some content inside the cooperative snapshot 0 in the failed replica. And similarly for snapshot 1, the same result is almost full, right? After that, if we rebuild these two new, continue to do full rebuilding for these two new snapshot, then the overall rebuilding will get finished. So as you can see here, it's already finished. That's the power of the new fast rebuilding for V2 volumes. And by the way, if you enter into, let's say, instance manager, which manages the replica for Longhorn volumes, and if you run this special binaries, which is mainly for Longhorn developers debugging for V2 data for V2 engines, you will see those kind of content. Let's say each logical volume or each entry is listed here is actually a snapshot or the current volume head. Then if you run this sub command, let's say with, for example, with starting index 0 and with and with the snapshot content, let's say 10 for one snapshot, for one random snapshot listed above. Let's just pick the existing snapshot here. Oh, it's a bunch of 0 because we don't have such content. Let's switch to another one. Yeah. Let's say for the snapshot 2, for the first 10 data chunks or first 10 clusters, which means the first 10 megabyte data, here is the checksum result for each cluster. You can see they are stored separately, which indeed help our rebuilding before, as we shown here. And besides, if you check the let's say for the rebuild, for example, this volume, this replica is the replica we just rebuilt, and Then if we enter into this, the corresponding incident manager, we can see the let's say in detailed result for each rebuild snapshot. Let's run the same command again. Then in this step, we will verify if the rebuild content matches the result from other healthy replica. Let's say here, this is the result we just recorded during the rebuilding. And this one, as you can see here, the progress bar here, this is the content from a healthy replica, which are all identical, which means for this rebuilt snapshot in the rebuilding replica, the content is correct. And similarly for snapshot 1, you can see here, snapshot 1, the content is correct. And for snapshot 0, yes, similarly, that the result is identical. And then for snapshot 2, which is the very first snapshot list here, so the result is still identical. As for Y, some of the Y in the healthy replica, some snapshot does not have the checksum because when we listed the results of this healthy replica, some snapshot count are not calculated yet, are still in the progress. The calculation is still in the progress, so it should be fine because anyway, the data content is already calculated in advance. I mean, when we run the script, as long as the final, let's say, result in the rebuilding replica matches the result listed in the script, then the data should be identical. After this, we will be verified that the rebuild content inside this new or rebuilding replica is intact and healthy. And I think that's all for this demo. Then since there are no new audience during the meeting, then we will skip the QA. And I think that's it for my introduction. So let's get back to you.
Yeah, thank you so much, Sho, for doing that. It's absolutely wonderful that we went through all these features, and the recording will be up for posterity in case people want to refer to it later on after this meeting gets done as well. So, yeah, with that, I think we can conclude this meeting and give you back some time in your day, which is just starting. And for the rest of the people who are interested in joining these meetings, please do join them and ask us questions about any of the features or any of the burning issues or concerns that you have with the project. We'd be happy to take them on the meeting itself, but also we are available on the user Slack, which is the Ranchi user Slack, as well as on the CNCF Slack as well. With that, it's see you at the next meeting from me, and have a great day. Bye.
Have a great day. Bye bye.